sure you've seen the more recent evidence of a crater that they just discovered, like fairly recently.
Greenland.
Yes,
Yeah.
enormous crater.
It's an enormous crater.
Beneath the icy expanse of Greenland, scientists have uncovered something that defies all expectations, sending shockwaves through the global community. What lies hidden beneath the frozen surface? How could something so extraordinary remain concealed for so long? This revelation not only challenges what we thought we knew about our planet, but also leaves us questioning what other secrets the Earth might still be hiding. Unveiling the secrets of the Greenland ice sheet. Let's take a journey back in time, millions of years ago, when the Earth was a very different place. The Greenland ice sheet, which now covers about 80% of Greenland, started forming during the Pleistocene epoch. Imagine snow falling, layer after layer, year after year, slowly compressing into thick ice. Over time, this ice spread out, covering almost the entire island. It's amazing to think about, right? Today, the Greenland ice sheet is a massive frozen expanse, second in size only to the one in Antarctica. It stretches about 1,500 miles from north to south, and at its widest point, it's nearly 700 miles across. Now, here's something that might blow your mind. The ice can be up to 10,000 feet thick in some places. That's nearly 2 miles of solid ice. And all that ice adds up to about 7% of the world's fresh water, just sitting there, frozen. But the ice sheet is more than just a giant block of ice. It holds a lot of history within it. Scientists can drill down and pull out ice cores, long cylinders of ice that have trapped tiny bubbles of air from thousands of years ago. By studying these, we've learned about past climates, volcanic eruptions, and even how our atmosphere has changed over time. So this ice sheet is like a natural time capsule, giving us clues about Earth's history. Now, let's talk about why the Greenland ice sheet is so important. It's not just a big chunk of ice, it actually plays a huge role in keeping our planet's climate in check. Think of it as a giant mirror. Its bright white surface reflects a lot of sunlight back into space, which helps to keep our planet cool. This effect, called the albedo effect, is crucial because it helps balance out the energy that the Earth receives from the sun. But the ice sheet doesn't just sit there reflecting sunlight. It's also connected to our oceans and atmosphere in a pretty big way. The ice sheet influences the global thermohaline circulation, often referred to as the ocean conveyor belt. This system of ocean currents moves heat around the globe, affecting climates from the tropics to the poles. During warmer months, when some of the ice melts, fresh water flows into the North Atlantic Ocean. This can change the density and salinity of the ocean water, potentially messing with these currents and, in turn, altering climate patterns worldwide. Here's where it gets a bit scary. If the Greenland ice sheet keeps melting at the rate it is now, we could see some major changes to our climate. For one, if the ice keeps shrinking, the planet will absorb more sunlight instead of reflecting it, which could speed up global warming. And if more fresh water enters the ocean, it might weaken a crucial part of the ocean conveyor belt, the Atlantic Meridional Overturning Circulation, AMOC. This could lead to more extreme weather. Think harsher winters in Europe and changes to monsoon patterns in Asia and Africa. And let's not forget about rising sea levels. Even a partial melting of the Greenland ice sheet could cause sea levels to rise by several feet. This would have a huge impact on coastal communities around the world, not to mention the ecosystems that depend on the ice. Polar bears, seals, and other Arctic animals could lose their habitats, and millions of people living in coastal areas could be displaced. In short, the Greenland ice sheet is more than just a frozen wonderland. It's a key player in our planet's climate system. Understanding its history, its role in regulating the Earth's climate, and the potential consequences of its melting is crucial, especially as we face the challenges of global warming. The future of this ice sheet isn't just about Greenland, it's about the entire world. Discovering the hidden world, cutting-edge research. Imagine trying to see what's hidden beneath nearly 2 miles of solid ice. Sounds impossible, right? Well, thanks to some pretty incredible advancements in technology, scientists have been able to do just that. It all starts with radar and satellite technology, which have taken huge leaps forward in recent years. These tools have allowed researchers to peer through the ice and reveal what lies beneath the surface of the Greenland ice sheet. The process begins with aerial surveys, where planes equipped with ice-penetrating radar fly over the ice sheet. This radar sends signals down into the ice, which bounce back when they hit something solid, like bedrock or water. By analyzing the time it takes for the signals to return, scientists can create detailed maps of what's underneath the ice. It's like using an X-ray to see inside the Earth. But it's not just about flying over the ice. Remote sensing from satellites plays a huge role, too. Satellites orbiting high above Greenland use various types of sensors to gather data. They can measure changes in the ice sheet's surface, track its movements, and even detect tiny variations in gravity that hint at what's happening deep below. All this information is pieced together to give scientists a clear picture of what lies hidden beneath the ice. These technological advancements have opened up a whole new world for researchers. For the first time, they've been able to map out subglacial lakes, rivers, and even entire mountain ranges that were once thought to be impossible to see. These discoveries are not just exciting, they're crucial for understanding how the Greenland ice sheet is behaving in response to climate change. So, who are the people behind these groundbreaking discoveries? The research teams involved in this work are made up of scientists from all over the world, representing some of the most prestigious institutions in the field. Universities, research centers, and government agencies have all come together to pool their expertise and resources for this monumental task. One of the key players in this field is NASA, which has been involved in ice sheet research for decades. Their Operation Icebridge mission, which uses aircraft equipped with ice-penetrating radar and other sensors, has been instrumental in mapping Greenland's subsurface. NASA's data has provided the foundation for many of the discoveries we're seeing today. Another major contributor is the European Space Agency, ESA, which operates satellites like Cryosat-2. This satellite is specifically designed to monitor changes in polar ice, providing high-resolution data that helps scientists track how the Greenland ice sheet is evolving over time. But it's not just about the big agencies. Universities like the University of Cambridge and research institutes like the British Antarctic Survey have been at the forefront of this research as well. These teams often collaborate on large-scale projects, combining their expertise in glaciology, geology, and climate science to push the boundaries of what we know about Greenland. What motivates these scientists? For many, it's a combination of curiosity and concern. The Greenland ice sheet holds many secrets, and unlocking them is key to understanding our planet's past, present, and future. Some researchers were driven by previous hypotheses suggesting that there might be vast networks of water beneath the ice. These ideas were based on clues from other ice-covered regions, but no one knew for sure what was hiding under Greenland's ice. Their efforts are also fueled by the urgent need to understand how the ice sheet is responding to global warming. As the climate continues to change, the Greenland ice sheet is melting faster than ever before. By studying what lies beneath, scientists can better predict how the ice will behave in the future and what that means for sea levels, climate patterns, and ecosystems around the world. What lies beneath? The unexpected findings. When scientists first started peering beneath the Greenland ice sheet, they expected to find a pretty barren, frozen landscape. What they discovered instead was something straight out of a prehistoric world. Beneath all that ice lies a hidden landscape of ancient mountains, deep valleys, and intricate river systems, features that have been untouched for millions of years. These mountains and valleys are part of a landscape that was once above sea level, shaped by the same forces that carved out the continents we know today. Before the ice took over, Greenland was home to a vibrant environment, with rivers that flowed through lush valleys and mountain ranges that would have rivaled some of today's tallest peaks. The ice sheet has been so effective at preserving these features that scientists can study them almost as if the ice had only just covered them up. The discovery of this ancient landscape is not just a geological curiosity, it provides valuable insights into how Greenland's environment has changed over millions of years. For example, these mountains and valleys were likely shaped by the same tectonic forces that are still at work today, slowly shifting and altering the Earth's surface. By studying these features, scientists can learn more about the history of tectonic activity in the region and how it has influenced the landscape over time. What's even more fascinating is that these valleys and river systems once supported a rich and diverse ecosystem. Before the ice covered Greenland, it wasn't the frozen, inhospitable place we think of today. Instead, it was likely a verdant landscape, teeming with life, a stark contrast to the icy wilderness that now dominates the region. As scientists explored further, they began to uncover something truly astonishing: fossils. These aren't just any fossils, but the remains of plants and animals that once thrived in a much warmer Greenland. The discovery of these fossils has turned our understanding of Greenland's past climate on its head. The plant fossils suggest that Greenland was once home to forests and meadows, with a climate that could support a wide variety of vegetation. Trees, shrubs, and flowering plants covered the land, providing habitat for numerous species of animals. This lush environment existed during periods of Earth's history when global temperatures were much warmer than they are today. Animal fossils, though less common, provide further evidence of this warmer climate. These fossils include the remains of creatures that could only have lived in a much milder environment, far removed from the harsh, icy conditions we associate with Greenland today. The presence of these fossils suggests that Greenland once supported a thriving ecosystem, complete with herbivores, predators, and a complex web of life. These findings are crucial for understanding Earth's prehistoric climate and ecosystems. They show that Greenland, now one of the coldest places on Earth, was once a temperate paradise. This transformation from a warm, green landscape to an icy wilderness offers key insights into how global climates can change over time and how life on Earth adapts, or fails to adapt, to these changes. The fossils also provide a glimpse into the types of species that lived during these warmer periods, helping scientists to reconstruct ancient ecosystems and understand how they functioned. Among the most remarkable discoveries beneath Greenland's ice are the fossilized remains of ancient river systems. These rivers, now long frozen and buried, once flowed freely across the landscape, shaping the valleys and feeding the ecosystems that thrived there. These ancient rivers likely played a crucial role in the region's ecosystem, providing water to the plants and animals that called Greenland home. The river systems were likely extensive, winding their way through valleys, cutting through mountains, and eventually emptying into the ocean. Over time, as the climate cooled and the ice began to form, these rivers were frozen in place, their channels preserved beneath the growing ice sheet. Studying these river systems offers a unique window into the past. By mapping out the courses of these ancient rivers, scientists can learn more about the hydrology of prehistoric Greenland, how water moved through the landscape, how it shaped the terrain, and how it supported the life that once flourished there. These rivers also provide clues about the timing of Greenland's transition from a lush, green landscape to the icy expanse we see today. For instance, the point at which these rivers stopped flowing and became locked in ice can help scientists pinpoint when the climate began to cool and the ice sheet started to form. The discovery of these ancient river systems also has broader implications. It suggests that similar processes may have occurred in other parts of the world where ice sheets now dominate the landscape. By studying Greenland's ancient rivers, scientists can draw parallels with other regions, helping to build a more complete picture of how Earth's climate has changed over millions of years. The impact on climate science. The discoveries beneath Greenland's ice are more than just a fascinating glimpse into a lost world. They're a game changer for climate science. One of the most significant impacts is how these findings challenge and refine our understanding of Earth's historical climate patterns. For years, scientists have relied on ice cores, sediment records, and other methods to reconstruct past climates. But the hidden landscapes beneath Greenland offer direct, tangible evidence of what the planet was like millions of years ago. The existence of ancient, lush landscapes, fossilized plants, and intricate river systems beneath the Greenland ice sheet suggests that Earth has experienced periods of warming far more dramatic than previously understood. These warming periods occurred long before human activity began influencing the climate, indicating that natural processes can trigger significant temperature shifts. This evidence forces scientists to reconsider how these warming periods affected the ice sheets of the past. If Greenland was once a temperate, vegetated region, then the ice that covers it now must have formed much more rapidly than previously thought. This realization challenges existing models of how quickly ice sheets can grow and retreat, providing new insights into the mechanisms driving these changes. Moreover, these discoveries provide a clearer picture of how past warming periods influenced sea levels. During these times, when Greenland was ice-free or had significantly less ice, global sea levels would have been much higher. Understanding these historical patterns helps scientists develop more accurate models of how current warming trends might affect ice sheets and sea levels in the future. This new information could lead to revised estimates of how much and how quickly sea levels might rise, which is crucial for preparing coastal communities worldwide. The implications of these discoveries extend far beyond the history books. They're poised to reshape how we predict the future of our planet's climate. Current climate models, which guide everything from international climate policy to local environmental planning, rely heavily on historical data to project future changes. The new findings from Greenland suggest that some of these models might need significant adjustments. One of the most immediate impacts could be on our understanding of sea level rise. If Greenland's ice sheet has undergone dramatic changes in the past, it could be more vulnerable to current warming trends than previously thought. This means that projections for sea level rise could be underestimating the potential for rapid, large-scale ice loss. As a result, climate models may need to account for the possibility of more abrupt changes in Greenland's ice sheet, leading to faster and more severe sea level rise than anticipated. These discoveries could also influence predictions about global temperature shifts. If the Earth has experienced rapid warming events in the past that led to the melting of large ice sheets, it suggests that our planet's climate system can respond to changes in more extreme ways than current models predict. This might mean that future warming could trigger feedback loops, such as the release of greenhouse gases from thawing permafrost or changes in ocean circulation, that could accelerate global warming beyond current projections. Incorporating these new insights into climate models will require scientists to rethink some of the assumptions underlying their predictions. For instance, they may need to consider how quickly ice sheets can melt and grow, how past warming events influenced global climate systems, and how these patterns might repeat in the future. These adjustments could lead to more accurate, albeit potentially more alarming, predictions about the pace and impact of climate change. The discoveries under Greenland's ice have added a new layer of urgency to the global conversation about climate change. While scientists have been warning about the dangers of global warming for decades, these findings provide fresh evidence that our planet's climate can change in dramatic and unpredictable ways. This has significant implications for how we approach climate action. For scientists, these discoveries underscore the need for more research and better data to understand the potential risks we face. The hidden landscapes beneath Greenland are a reminder that there's still much we don't know about our planet's climate system. As such, continued investment in climate research is essential to ensure we have the knowledge needed to make informed decisions. Policymakers, too, are likely to feel the impact of these findings, with the potential for more rapid and severe climate impacts than previously thought. There may be renewed pressure to implement stronger measures to reduce greenhouse gas emissions and adapt to the changes that are already underway. This could lead to more aggressive targets for reducing carbon emissions, increased funding for renewable energy, and stronger regulations on industries that contribute to global warming. Environmental groups are likely to seize on these discoveries as further evidence of the need for urgent action. The new insights from Greenland provide a compelling narrative about the potential consequences of inaction. As the realities of climate change become more apparent, these groups will likely intensify their efforts to push for meaningful change at all levels of society. In the broader public discourse, these findings could help shift the conversation about climate change. Instead of focusing solely on the slow, gradual impacts that have been predicted, there may be a greater emphasis on the possibility of more sudden and severe changes. This could lead to a greater sense of urgency among the public and a stronger demand for action from leaders. The role of ancient life, uncovering Greenland's pre-ice history. The fossil evidence found beneath Greenland's ice sheet has revealed a fascinating glimpse into a time when this now frozen land was teeming with life. Before the Ice Age, Greenland's landscape was rich and vibrant, hosting a variety of plant and animal species that today seem unimaginable in such a cold and barren environment. The fossils suggest that Greenland's ancient landscape was more akin to the temperate forests of North America or Europe than to the Arctic tundra we see today. This lush environment supported diverse wildlife, ranging from towering trees to a variety of fauna, creating a stark contrast to the icy expanse that currently dominates the region. While no direct evidence of human habitation has been found beneath the Greenland ice, the discovery of a once thriving landscape raises intriguing possibilities. It's speculated that ancient humans could have inhabited or at least migrated through Greenland during its ice-free periods, adding a new dimension to the study of early human migration patterns. If further evidence supports this theory, it could reshape our understanding of how early civilizations spread across the globe, suggesting that Greenland may have been a crucial, albeit temporary, stop for ancient travelers during warmer climate periods. The future of Greenland, what this means for the modern world. As Greenland's ice sheet continues to melt due to global warming, the ancient landscapes buried beneath could once again see the light of day. This melting process is not just revealing the secrets of the past. It's also contributing to rising sea levels, posing a significant threat to coastal regions worldwide. The newly uncovered terrain could also change dramatically as the ice recedes, potentially transforming into habitable land or exposing new geological features. The revelation of what lies beneath Greenland's ice could spark significant economic and political interest. As the ice melts, it might expose valuable resources like minerals, oil, and gas, leading to a surge in exploration and potentially sparking debates over ownership and environmental preservation. Greenland's strategic importance could increase, prompting discussions on how best to balance economic opportunities with the need to protect one of the world's last great wildernesses. The scientific community has been abuzz with reactions to the groundbreaking discoveries beneath Greenland's ice. Climate scientists and geologists have expressed both excitement and concern, with some hailing it as a major breakthrough that could redefine our understanding of Earth's climate history. The findings have also sparked ongoing debates, particularly regarding the implications for current climate models and predictions of future ice sheet behavior. The discovery quickly became a global media sensation, with headlines capturing public imagination and concern. News outlets highlighted the potential impacts on climate change, fueling discussions about environmental degradation and the urgency of climate action. The public's response has been a mix of fascination with the ancient world and anxiety over what the discovery means for our planet's future. Governments and policymakers around the world have taken note of the discovery, with several issuing statements acknowledging its significance. Some have suggested that these findings could lead to shifts in climate policy, emphasizing the need for stronger international climate agreements and increased efforts to mitigate the effects of global warming. The recent discovery under Greenland has stunned the scientific community and the world. For more fascinating updates, click on the video popping up on your screen. Don't forget to like and subscribe to stay informed.